So if you've ever gone to take the cross product of unit vectors and you just kind of got stuck, you got confused, and you feel like everyone else is just getting it faster and before you, I just want you to pause really quickly because there's nothing wrong with you. It's quite a common experience. And the real issue is just that someone hasn't explained it well enough to you. So that's what we're gonna do today. Now in this channel, we're all about covering all the little details that we possibly can about physics so that we can feel capable, energized, and just sharp all around. So in the next couple of minutes, we're gonna learn a really simple geometric shortcut that I like to call the unit vector cycle, which is going to help us solve the cross product of these vectors extremely quickly and easily. So let's get started. And here's your first win of the day. Remember the formula for cross products is equal to simply the magnitude of your first vector times the magnitude of your second vector times the angle between them, right? Okay. Now the good thing about unit vectors is that when you do this, since their magnitudes are both just 1 and the angle between them is 90 degrees, the magnitude of this unit vector, this third vector, is going to be 1. So that's a rule that I want you to know. The magnitude of the resulting vector between two unit vectors, it's always 1, or in other words, it's always going to be a third unit vector. So now that we've solved for the magnitude of this third resulting vector, we of course are only left with one thing, and that is to solve for the direction of this third vector. So we know it's a unit vector, now we just need to ask ourselves, in what direction does it point? And we solve this using something called the right-hand rule. Now, if you're not 100% comfortable with the right-hand rule just yet, I actually made a quick 2-minute breakdown earlier that you can click on the top right to watch here, and I promise it's gonna make it all make sense super quickly. And before we make use of this, we need to lay down one ground rule, and that is that the coordinate system that we're working with has to be a right-handed coordinate system. And I'm gonna cheat a little bit because I always define a right-handed coordinate system as one in which the unit vector cycle, which is the trick we're gonna be learning, works. So I'm just going to show you real quick one that we're going to be working with, and it's going to be I hat pointing this way, J hat upwards, and K hat towards us here. This is a right-handed coordinate system because this vector cycle that I'm about to draw here works within this coordinate system. Now this cycle is the important part of this video, right? So here's what it's telling us. When we take I cross J, we're going in this direction, right? Imagine crossing in this direction, and your result is going to be K, just the next one down. So I cross J is equal to K hat. And if you were to do J cross I, your result would be I hat. You just keep on going clockwise in the cycle. So your question is, what if you do K hat cross I hat? Well, you're going to get J hat. As long as you move counterclockwise within this cycle, you get the positive version of the resulting vector. Now, let's ask the question, well, what if we move in the opposite direction? What if we go and do this, right? The arrows are pointing the other way. So now we got a different version. We have J cross I, what's that equal to? We have I cross K, what's that equal to? And what's K hat cross J? Well, it's still going to be equal to the third vector. However, this time it's the negative version. So J hat cross I is equal to negative K, I hat cross K is equal to negative J, and K cross J is equal to negative I. I sincerely apologize for my writing, my handwriting. Okay, so that is the shortcut, guys. Remember, we already solved for the magnitude of the third resulting vector. When you take the cross product of two vectors, you're given a third vector. And of course, like any other vector, it has a magnitude, which I'm going to call magnet as a direction. We solved for its magnitude when we used the formula like this, and we solved for its direction by using the unit vector cycle. So with these two tools, you know absolutely everything there is to know about the cross product between two unit vectors and two vectors in general. And that's it. It's clean, it's predictable, there's absolutely no guesswork, and the point isn't to memorize more rules, it's actually just to remove the cognitive load that you already have so you can spend your time focusing on the bigger picture of the problem you're working on. Now, if this gave you value in any way, I'd love to hear from you down below. Did the unit vector cycle click for you, or where did it start to sort of blur out? I always read the comments and I use them to make the next video better for us all.